And welcome back. This is the Kinect for Windows SDK beta launch.
That's right.
I'm Dan Fernandez.
I'm Gavin Janke, and I'm General Manager of Engineering for Microsoft Research.
Awesome. And Gavin, you know, we've seen a couple examples. Jeff and Anoop kind of level set. This is really the section where we're going to talk for developers.
That's right. Yeah.
We're going to talk about the API, give them kind of level set on how you can program, and we're going to do a lot of demos.
Exactly. Very cool demos too.
Very cool demos. And there are some questions coming on Twitter. We have a Q&A following our session. Just a quick one. I'm going to ask it to you, Gavin. At 2CS asks, how do we send our feedback about the Kinect beta?
So if you go to their main website, which is research.microsoft.com Kinect SDK, there'll be a forums link up the top, and we'll use MSDN forums to gather feedback and answer questions about developing for the Kinect SDK.
Great. Great. Okay, so let's get started. Just kind of level set. The things we're going to cover are we're going to give you an overview of what the Kinect sensor is and its capabilities, what that means from a developer perspective. We'll show you how you can use the RGB camera, and during this talk we have a Kinect sensor over in the corner, so you'll see us point over to that Kinect sensor. That's where we're going to be pointing our demos, and you should be able to see it as well here. We're going to do a deep dive into depth data, and then skeletal tracking. And then finally, we're going to finish up with some audio. All right, so just kind of level set. Really want to explain what's going on when you have a Kinect. So there is an RGB camera. It's a regular video camera, and this returns still images, 640 by 480, 30 frames per second. It's a still image, you know, a color image, if you will.
Yep.
Now, to the left and right of that is a 3D projector, and that 3D projector is sending out infrared data. And on the left side is, and this is assuming you are the Kinect on the left side. On the left side, what it's doing is tracking the amount of time it took that infrared data to come back, and it sends you back distance data for each pixel.
Yep.
And we're going to get into this when we talk about the depth data. And the magic of software part is really where the magic happens. So not just do you get the depth data, but skeletal tracking takes that data and makes it into information. Right, and that's where you get the skeletal tracking.
Yeah, and you can pretty much choose whatever you want to get from the Kinect. So there's so many different scenarios you can use it, whether you want to use just the infrared portion to do a 3D acquisition of a room, or the skeletal tracking piece, or both, and so on. So
yeah, absolutely. And in addition to that, there's a 4-microphone array, and this mounts as a regular microphone. So that means if, after you install the Kinect for Windows SDK, you can use Windows Sound Recorder. You can just press record, choose your microphone, and choose the Kinect as your microphone, and it just shows up as a microphone
That's
array.
right, but it's a microphone that's on steroids, though, because inside of the Kinect there's actually 4 microphones. And with the software, you can actually determine, where in the room a specific sound is coming from. That's beamforming and sound source localization. And then we have some very advanced features such as echo cancellation and gain control.
Right.
So the microphone in the Kinect's really high quality.
Yeah, so if you have a Kinect and you're just looking for a microphone, you just, whether you know it or not, you have an amazing microphone.
That's right, yeah.
And then the last thing is the motorized tilt, and this basically allows you to control the up or down, and this isn't rated for regular use.
No, so
right?
we do put throttling in there so it doesn't overheat.
Right. And so you may find that the Kinect kind of stops, and really that's your code that's throttling so it doesn't overheat, because it's not something that should be happening all the time.
Right, because the Kinect was designed for the Xbox gaming scenario, and so in the PC environment we want to keep those constraints there too.
Right, but there is developer access to it where you set the angle, and one reason you may do that is just to kind of scan the room, maybe when your application opens, to see if the Kinect is on top of a TV. You want to make sure you have the right angle to see people.
Oh, that's perfectly fine, yeah.
But it'd be a one-time thing, if you will. So do you want to talk about the SDK architecture?
Sure. So so this is kind of a hybrid Windows architecture slide, and then also how the Kinect SDK is actually structured. So at the lowest level, there's Windows and the Kinect and the USB hub. The Kinect's actually 4 USB devices in one, and it has its own built-in little hub. And exposed through that, the Kinect driver exposes, essentially audio and audio is exposed as a regular Windows recording device. Then there's the pair of cameras, which is infrared, and also the VGA camera, which acts in a similar way to a webcam, although it isn't a webcam. And then motor control. Then higher level up, essentially, the Kinect API is split into kind of two. You have the audio APIs, and the Kinect audio APIs builds on top of the standard Windows audio stack, which provides the augmented capability for echo cancellation and stuff like that.
Sure.
So that's exposed to its own set of APIs. And then we have what we call the NUI API. And the NUI API...
and that stands for Natural User Interface, in case people aren't familiar with that term.
That's right. Sorry, mumbo-jumbo acronyms there. So the new API kind of gives you tiered access to the Kinect. So for a nuts and bolts developer who wants just access to the depth feed, they can just get the raw stream out of that. So we offer the VGA and the depth stream as raw if they wish. Then we have higher level augmented APIs, which is where we can produce up to 6 players being tracked in the depth stream, and then 2 skeletons, which can be actually rendered from those 6 track players.
Right.
And that's where we get the 20 points of joints for each skeleton. Obviously, motor control. So, the API we've actually tried to keep as close to the Xbox API as possible, so there's consistency between the platforms. There's a small differentiator, but like a few percentage points. So that's essentially how the SDK is structured in terms of the logical areas that we expose.
Yeah, I think it's good for people to get kind of the high-level view of all things happening. And, of course, we're going to jump into all those different areas that you just mentioned. So really what we got to do is show our first Kinect demo. So talked about the nuts and bolts. We are going to build from scratch a C# project. And what this is going to do is we just want to display the video and depth camera. So show you how to build Kinect. I have a Kinect plugin via USB. I'm going to say new project, and I'm just going to choose WPF application. So to get data from the cameras, you need to do 3 things. You initialize the runtime, you sign up for the event to receive a video frame ready or a depth frame ready, and then you have to open that stream. And you do have to make sure to open that stream, and that's when that event will fire. And it's going to send you back image data. So what I want to do is just, on our main window, we're going to add an image. And I'll just zoom in here so you can maybe see the properties of this image. And we'll just set it to 320 by 240. So the image width is 320, the height as 240. OK. So we have an image on our screen. And we're just going to start by displaying. I'm going to zoom out so you can kind of see this image. And we'll set our width to 800 for the whole page here. OK, so nothing real fancy. We have an image, and I just want to be able to show the video camera. Now, a couple things I'm going to do is add events. In here, we will add a loaded event, and I'm going to switch back to our form. And I'm going to add, and just do a quick search for the closed event. Now, so we have our form, our GUI kind of set up. The thing we need to do now is I've installed the SDK. I go to Add Reference. So in this reference dialog, I hit .NET, and we'll just kind of zoom in here. And I'm going to sort this alphabetically. And this is under Microsoft.research.Kinect. And so here we see the library. I'm just going to double-click it to add it. And I do have one more library because I'm going to use it. It's a Coding for Fun Kinect library that really does some of the most common tasks for image processing. It's not required by any means, but it's just a helper that's WPF specific. So I'm just going to double click on that DLL. OK, so we have those in here. Let's add references to them, and we're going to start talking code here. So I'm going to zoom in a bit. So hopefully you all can follow along there. OK, slowly. OK, so we will add a reference to Microsoft.research.Kinect.NUI, and that's the library Gavin was mentioning earlier for things like camera, skeleton, and the motorized tilt. And I'm going to add the Coding for Fun library as well. Now, what I want to do is create an object for that NUI, and that's the runtime object. And I'm just going to call it NUI equals new runtime. So when I start doing processing, the things I want to make sure to do is I initialize in the loaded and I uninitialize in the closed. Let's just do a quick NUI initialize here. And this is what we're asking the Kinect that we're going to use it for. So we are going to use the runtime options and say we're going to use the color camera. And this is an enumeration, so I just do a pipe and I can do another option. I also want to use the depth camera. Okay, so let's go into the closed and just make sure that we are being good citizens here and NUI uninitialize. Okay, so now that we've initialized, we're going to sign up for the event and then open the stream. So let's sign up for the event, video frame ready, plus equals, and I'll just have Visual Studio build the video frame ready event for me, and I'll get to that in just a second. But to have that event start sending us image, we need to make sure to open the stream. So video stream dot open. I say image stream type, and let's make sure my cursor doesn't go crazy. Image stream type. In this case, it's a video stream. And we're going to pass in a couple of parameters. Now, pool size, think of it almost like a buffer. You want to have at least 2, so that way if you're trying to read an image and the runtime's trying to write to an image, you don't have contention. So we'll just use 2. Oop. And it looks like it was looking for me to refactor something. So let's hit 2. Image resolution, 640 by 480. And I'm just going to hit enter here to put this on a new line. And the image type, this is going to be color. So let's just zoom out real quick. We're going to open a stream, a video stream that's 640 by 480, and the image type is going to be color. So at this point, this is going to fire, give us an image. We now want to display that on image source, the image 1 source. Zoom in a little. And we're going to do that. Actually, let's create a planar image that represents the data that's sent back. e.imageframe.image. And what this is because the Kinect SDK sends the data back, it doesn't send a UI-specific library. Like there isn't a UI library for WPF or for Windows Phone. The same data can be used across all of those. You need to do the last step, if you will, which is you give me data, I convert it to that specific UI library.
That's right, because you can use the Kinect SDK if you want to use GDI, WPF, Silverlight, XNA, so we don't tie you at the NUI API level what the data comes back like.
Exactly, exactly. So, so this data represent the actual bytes that represent that image. So we are just going to do an image.source equals, and we're going to create a bitmap source. Bitmap source.create. And this expects a number of parameters. We're just going to go through here. It needs to know how big it is. So we're going to do the width, the height, how many dots per inch, which happens to be 96 for both, the pixel format. So this image comes back as pixel format blue, green, red 32. So let's make sure I type correctly, BGR 32. And what that means is the order is blue, green, red for the bytes, and there's 32 in there. And the bitmap palette we can ignore. And the array of pixels, this is where the actual data that represents the image is. And that's under data.bits. And now the last parameter is something called stride. And you can think about it, when we're creating an image, we need to know how many bits do I really need to store. So because it's a 640 image, it's 640 times each of those colors. So blue, green, red, and the extra. And we can actually find out how many bytes per pixel there are by using data.bytes per pixel. Okay, so with any luck, we're going to hold our breath here and see if we can actually see a video camera. Ooh, does not fall within the valid range. Ooh, let me make sure I didn't. Oh, yes, 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 this is good. I didn't actually do I talked about the multiplication. I didn't actually do it. So 640 times 4. So width times bytes per pixel. Hey,
you
all
go.
right. Okay.
So how many lines did that take you to access video feed off the Kinect? Let's count them up.
Yeah, okay. This is now, I'm going to go into easy mode here. So as you can see, some of these things may trip you up from a parameters, especially if you haven't, say, done, you're not familiar with stride or how you have to calculate bytes. So we do have the helper library, and I'm going to uncomment this out and just say image1 dot source equals e dot image frame, and I have a extension method. And that extension method does the exact same thing, but it basically makes it, you know, one line of code to do this. So let's see if we can get this working. Same exact result. Yes, yes. But it's important for developers to know what's going on under the covers and that you're getting data back. It's not UI specific. So let's go back to our GUI, and we're going to add one more image on here. Oh, you know what? Instead of this, I will let's delete that. I'm going to copy and paste this image so I don't need to resize it and save us some time. So that's image 2, and it's the same size. And let's jump back into our code. So because we have this depth, I want to show you the depth data and how to visualize that depth data. We're going to add, do the same things we did before. We're going to, since we've initialized, we're going to add the frame ready event and then open the stream. This time we're going to do it both for the depth frame. Plus equals tab tab. And we'll do one more. GUI dot depth stream dot open. And we're just going to say that I'm now passing in a depth image. And we'll set the pool size to 2 again. And this time we'll do the resolution of 320 by 240. And the image type is of depth. So we have the frame ready, the open, and since I don't want to get too much into the nuts and bolts of changing a distance and the distance, we're going to cover that in just a few. I'm going to use the coding for fun cheat and display the image.source equals e.imageframe.2bitmap source. And let's run this. And now what you see on the right side is depth, and the way this works is it scales the color. It's a monochrome, scales the color based on how far or how close you are. So as you see, my hand goes back and forth. It gets either lighter or darker.
My hand, because I'm further back, is much darker.
Yeah, exactly. Okay, so nothing like live coding. Okay, so we've seen kind of the high-level stuff. Let's jump back in. And how you can use the RGB and depth camera for your applications. We're going to do a deeper dive into that depth data, because we kind of did that one thing. We showed what's going on and we see different colors. Really what we want to explain is the depth data coming back. So the depth data is, think of it this way, it's the distance from the Kinect for every pixel. So if pixel 0, 0, imagine a 320 by 240, pixel 0, 0, I'm going to know how far away that pixel is from the Kinect. Now, optionally, as you said, includes the player proposal data.
That's right. So it's all packed up, you know, into the data that comes back in the event handler.
Right.
And you have to unpack it with bit shifting and stuff. But it's pretty straightforward, and the example code shows you how to do it.
Yeah, so it's good to know that you can also get player data, not just distance data. Now, so what's going on under the covers? So the image frame is in that image.bits. Well, in the color image, we had, you know, what the visual representation. This is now an array of distances, if you will. So for 0, 0, this is the distance. For, you know, point at 320 by 240, this is the distance. And this is in that public byte array bits. And the way these images work is they stop top left of image, and they basically, you know, go rows typewriter style, if you will, left to right in terms of navigating that array. And each one represents that distance. So the formula here, it depends, is the answer for the formula. But if you're using the depth, it's distance per pixel, and it's the second byte by 8. So we are doing a bit shifting operator here on the second byte. And remember, these are 2 bytes. So if I want to get the distance of 0, 0, I actually ask the array for bit 0, which is number 1, and the second one, which is bits 1. So with those 2, you combine and can actually get the distance. The data returned is in millimeters, right?
Meters.
I think for depth it's millimeters,
Oh, okay.
and then
yeah,
skeleton.
That's right. The skeletal stuff, yeah.
But it's all based on the distance from Kinect, right?
Yeah, so I think in the next slide it shows. Is that
Okay.
right?
Yeah, so just before we jump to that, the only difference with player index is we do have to, because that player index is the 3 first byte there, we do have to do a bit shift to get that data. Okay. Yeah, so this is the high level reference. 850 millimeters to 4,000. And what I've seen is it doesn't really count down all the way to 0. It shows kind of if you hit 850, it'll always return 850.
Right.
Same thing with 4,000. There are some times when the depth value is unknown. So low reflectivity, maybe it's glass or something weird that isn't causing that infrared data to bounce back. It's just going to give you 0 or a high reflectivity as well. And you do the way the player index works is 0 means that specific point doesn't represent a player, or it represents a specific skeleton or the body parts. All right. So best shown through code. So what we're going to do is just show some of these formulas in action. And you saw what we were doing from scaling colors. That was actually, if you think about colors, they are a value from 0 to 255. What we're going to do now is just do a really simple one. Instead of scaling the value based on distance, we're going to say you're going to be a set of 3 colors. And the best way to explain this is kind of just show it in action. So this represents, blue represents we're really close to the Kinect. Green is we're in the middle, and Gavin, if you want to wave there, that is really far away. So what you can do is, and we're going to walk through this code, is do specific actions or do specific events based on how far certain parts of the screen are, do different colorizations, visualizations, or act on that data as well. So you can do things like for all bits that are close to, at this minimum distance, do this particular action. Get the average, and therefore, maybe it's a hand application. We did this for our Jelly Bean application where we're using the average distance, take all the points that are at least at this distance, get the average, which ends up being about the middle of your hand, and then using that as kind of a cursor. And again, this is the low-level stuff. We're going to talk about the higher level things, so you don't have to do this level of bit shifting. But for people that want access to that, everything is available. Now, what I'm going to do is just show you this code at a very high level. The same stuff we did before. We haven't initialized. This time we're using depth and player index. We have the depth frame ready, and we're going to open the stream. So the same exact events. Now, the data that's returned for depth frame ready is distance data. It is an actual visual. So we need to, you give me the distances, I will give you back a way to visualize those distances. And that's what this formula does. So we pass in an image frame. We do a couple things to calculate the heights, but really this is going to be the container of what we're going to return. It represents all the colors. So the color format we're going to use is blue, green, red, 32. So you see the indexes here. The first one's blue, second one's green, third one's red. And if you were using BGRA 32, you can actually use transparency. So you can do kind of like, I'd call it a poor man's green screen, if you will. So you can set transparency on somebody going on and off. And we do have an example of that. Now, jumping into this code, what we're going to do is do that same looping of code left to right, typewriter style. So Y is, we're going to be going through the X values of 0 to 320 multiple times, and Y is the outer loop. So at this point, get distance with player index, we're at a specific pixel, if you will. And we pass in the depth index and the depth index plus 1 because we have 2 values. So let's just show that formula, and it really is nothing special. It's the same thing that we did. It's that distance formula. Now we have the distance in millimeters for that particular point. So with that, what I'm going to do is a very simple formula. If we're really close, I am going to set in a value of 0 to 255. 255 is the maximum. I am going to set, if you're really close, full blue. Full blue. What if you're kind of in the middle, and that's where most of my body was? We're going to do full green. 0 to 255, and we're using that distance data. And now if you're really far away, and that's where Gavin was raising his hands, you saw that he was, we'll just set that to full red. Now a couple things that you can do is actually color body as well. So I'm just going to uncomment this. And one thing to note too is because we do need two values to calculate that distance, we are, every time we loop, we jump by 2. Okay, so in this case, we're going to do full green and full red if we have a player. So let me just show you, and really it's any player that's returned. We pass in the first frame, we do a bitwise AND on it, and that'll let us know it's either going to be 0, 1, 2, 3, 4 if we had a lot of people in here. So hopefully the demo gods will start tracking here, and if I don't kill myself, we will. Yeah, so there you see that full combination gives you that nice gold look. So what that's doing is it knows the pixels of those player proposals that you were mentioning before,
yep.
And then we can color based on that. Okay. So that's the real, as you were saying, the nuts and bolts.
The nuts and bolts.
The higher level stuff is when we talk about skeleton data. So do you want to talk just quickly about, at a high level, what's kind of returned and how people program the skeleton data?
So if you imagine, so this kind of XYZ coordinate system. So if you imagine the front of the Kinect sensor, if there's an imaginary ray which goes up perpendicularly directly out of it, then the X, Y, and Z is all in proportion to that imaginary ray. And that is in meters. So you have the depth, the X and the Y, all in proportion to where that imaginary beam comes from. And so we have 20 points, essentially, which are returned for the various joints in the body. And as you see here, these are at the different points that the Kinect skeletal algorithm returns to you, in this X, Y, and Z format.
Okay, cool. So just thinking about this, the other stuff I think we mentioned before, the real things to take away from here is that you can also find out if a joint has associated state. So whether it's tracked or not tracked. So if you're real close to the Kinect, maybe it isn't seeing your feet or anything below your knees. So it'll tell you whether it's not tracked or maybe it's inferred. You can imagine if it has 2 joints, and this is just an example, if it has 2 joints, maybe my elbow's off screen, but it can kind of calculate where it thinks it is based on those other joint positions. But it is something to check for. And you can also find out information if it's clipped or that sort of stuff. Now, one important point is, and we're going to show this in a demo, is you can use joint smoothing. This is built in. This is probably one of the key things that developers are going to want to do when they first do skeletal tracking. It's very easy, but sometimes the joints have noise.
Right.
And what I call is noise is if you're getting, say 30 frames per second of a skeleton, that skeleton could be moving. One of those points could be a little off.
Right.
And if you're drawing something on every motion, it seems off. So what this allows you to do is remove that high frequency or those spikes. And it's all built in. You have to set the transform smooth equal to true. And you can set default transform parameters, or you can fine tune things like correction, jitter radius, max deviation radius, all these different things to kind of control it. Let's just jump into demos here. So the first demo that I want to show. Do you want to do your demo
so that's
first?
a C++ on, yeah?
Yeah, I'm going to let you drive and see.
Change the guard.
Yeah, since we're going to be
All right, let's fire it up. Let's see, skeletal viewer. There we go. So let's just run the application first. So essentially the skeletal viewer app, as you see, here's the track skeleton. In the top left-hand corner is the depth image with the player identification. Right-hand side is the VGA feed, and then obviously in the center, we have our skeleton tracking. So, and there's Dan, sitting down, in fact.
Nice.
So let's go to the code and see what's actually happening. So the way I created this sample, in order to make the UI and everything straightforward, It's a regular Windows 32 app, and the UI I created as a dialog box just for ease of control, positioning, and everything like that. And we can have actually we can't see that in here, but essentially, you define in a visual editor, where each box and buttons are going to be. So in skeletalviewer.cpp, this is your typical Windows app structure where you have your application entry point, and we're actually creating a dialog box directly here and our message loop, and then this is our window proc for a dialog box. And the functionality of the application I actually encapsulated in a C++ class just for ease of variable states and that kind of thing. So when the dialog's created, essentially we just set all the member variables to 0. We remember what our hwind is, and then the real nuts and bolts is in this line of code here, which we'll look at in a moment. And then just setting the font for the frame rate. Everything else, there's really not much more to it. When the application destroys, we uninitialize the NUI layer and then quit the application. So that's Windows Programming 101. So looking at the nuts and bolts of the code itself. So here's a structure which is just the joint color table. So if you recall, our skeleton in the center had different colored joints. This is just that table. So,
and these represent the colors that you're coloring each little circle, if you will, right?
Exactly. So we always know the head is colored red or something like that.
Right.
So when the class is created, we just initialize everything nicely to 0 or default values. So NUI init. So this is essentially what Dan did in C#, but this is in good old C++. So in a similar fashion to setting event handlers, the way we're going to do it in Win32 is using Win32 events. So there's 3 events here, obviously depth, video, and skeletal. And when the NUI layer has a frame ready in each of one of those, it signals the event, and you'll see the code which deals with those in a moment. This code here essentially sets up sizing for off-screen rendering of the bitmap so that it's nice and smooth when we render the skeleton to the screen. So we actually use Direct3D to do the rendering of the depth map and the VGA feed. So what we're doing here essentially in create device is creating the Direct3D class. We have a little helper class called draw device here. I'm not going to go into the details of this, but essentially it creates a Direct3D surface on that window so that we can render the bits. So going back to NUI impl, we create that rendering surface for the depth viewer. We're telling it that it's going to be of this video size and format. And then essentially we do exactly the same for the VGA feed coming off the Kinect VGA camera and set its size. NUI initialize, just like in C#, we want the depth and player index. We're saying that it uses a skeleton. We want those values to come back and color VGA feed. Now, because this is Win32 and we're using event signaling, what we do is we tell the NUI layer that we want to use this Win32 event to be signaled when there's a skeleton being tracked. Continuing on, this is where we open the streams exactly in C#,
right,
saying we want this resolution, this color, this number of buffers. And here again, we specify the Win32 event that gets signaled in our thread handler when those frames are actually ready to be processed. So what we're doing is we're going to create a Win32 thread. So we're going to put it on the threads for ease of asynchronous handling of these Win32 events. We are going to create a stop event so that we can nicely shut down the thread when the application terminates, and then we create the thread itself. Uninitialized, not much there. We're just cleaning up some drawing objects. We're going to signal the thread to stop and wait for it. Going down, so this is our main thread function. Essentially, we set up the threads, the events that we wish the thread to be signaled upon. We wait on those objects to be signaled, and when an event comes in, essentially we do a a switch here, and we process the code in there. We do some other things such as frame rate, a skeleton blanking. Something that's interesting with the Kinect, it doesn't tell you when it's not tracking a skeleton. So you've got to put
that
logic.
event fires only when the skeleton, when we have a lock. If
Exactly. So we need to put in a little logic here so when a skeleton isn't being tracked anymore that we blank the screen. So some of your scenarios might need that. VGA, we're just using direct 3D semantics to render the VGA frame to the surface. Similarly with the depth frame, what we do here is because we're also tracking the player information, we need to strip that out to render it. And this function, NUI short quad to depth, actually does that. And then we just render it to the direct 3D surface. Going down to the skeleton alert, essentially what we do is we loop on the number of skeletons being tracked, which is up to 2. And if we have found a skeleton, what we do is we do that smoothing function so that joints are nicely smoothed, and essentially we see if a skeleton's being tracked, and if so, then we draw it. In NUI draw skeleton, just keeping this simple, what we do is essentially we draw the different, the trunk, the arms, and the legs in sequence, so that nice contiguous drawing operations in here, and then drawing the joints in a different color. So I'm not going to go into too much more detail, as there's a nice walkthrough in the online docs on how this application works.
Okay,
So,
cool.
Next one.
Actually, did you want to show the Earth?
Oh yeah, let's do the Earth
just
thing.
before.
All right, so we'll go do the Earth. So this is a very cool demo, Connect Earth Move, and I think someone only took a few minutes to actually create this, but I think it's really cool. So essentially someone has a spherical object, and what we have here is Kinect is tracking my shoulder and hand positions so that I can physically manipulate the world.
I love that. I love that.
And the further
Go big. Yeah.
my
Yeah.
hands.
Okay.
And you could do all kinds of fun things to this example, such as putting momentum behind the globe so that you can twist it. So this code, just like the other C# app, is very straightforward. This one's only 200 lines long, and that includes all the rendering too. So when the window loaded event is fired, we set off a little timer, and this is so that the Earth can just rotate at its own little speed if nothing's going on. Initialize the new runtime, saying that we want skeletal tracking and VGA color. We open the video stream, set up the events. When the VGA event is fired, essentially we render that to the video source. And then when the skeleton frame is ready, what we do is we make sure that a given skeleton is tracked, and then we extract the shoulder and hand information and so that we can do some logic.
So at that point, we had the X, Y, Z position of those joints.
That's right. So using X, Y, and Z, we're using, again, the 3D features in .NET, Vector 3D, to map that into that space so that we have a logical center of both of the hands. And then we actually move the globe with this transform using that logical center. Similarly, we use the shoulder and the squares of that and the hand to actually give size data and so on. And so essentially all we're doing is feeding that into the XAML for the globe transform, and there's a little helper function at the bottom which deals with the globe itself, its rotation, scale, and so on. So it's a real simple demo.
Great.
And just in a handful of lines code.
Cool, cool. So this is all, using skeletal tracking, and, we like to have fun here. So what I want to do is just show our coding for fun turret. So, a lot of people go into your office when you don't want them to. I have that problem.
I have a lock on my office.
Oh, that would. We have people that know how to defeat locks. I think.
Yeah.
Our hiring practices maybe aren't as good as your team's. But what we wanted to do was actually find out, using this data, actually save information when somebody's in your office. Isn't it nice to know we can use the Kinect skeletal tracking and take a picture of, say, somebody's when they're in your office?
Yeah.
So the other thing is we need a deterrent. So what we did, and I'm hoping I can get this working here, is, and I may need a volunteer, is added a little bit of a deterrent. So the way this works is we had a Nerf gun, and Clit Runkus spent just a couple minutes building the electrical signal. So it's a relay, if you will, that just opens a circuit, and hopefully I'll be able to get one of these folks to test this. So we can basically have this in your office, and what's going to happen here, and hopefully everything will work. I'm just making sure all the plugs are in. What's going to happen is when it finds a skeleton, it's actually going to start, well, shooting. That's exactly what's going to happen. So with any luck, this will actually work. Oh, you know what? I actually need to
move the Kinect.
I need to have the right Kinect plugged in. So we do have two Kinects. And the way this works is we've translated these positions. And I'm just going to put the Kinect here and make sure to plug in the correct Kinect. And we'll switch Kinects. And stay on target. Let's make sure. Ooh, 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 ooh. Let's make sure.
You may need to just wait a couple seconds for all the drivers to load.
Yeah. Okay. Let's just try and rebuild. And with any luck, this will slowly start to... Yeah! Oh, geez. Oh, look at it. Just get out of the way, man. So it's actually moving and tracking the position of the person. Like I said, we like to have fun, and of course, nothing is so much fun as really. Oh, look at that!
Nice.
Oh, look at those action shots!
Oh
my God! Oh, look at that! That is wonderful. So I can't. You can imagine. You know, this is a couple lines of code using skeletal tracking. You can send those to Twitter. So the next time the poor cleaning person comes into your office and you've pelted her with Nerf guns. So thank you, Carlos, for being our stunt double. And I think we just have a couple more demos on audio. That we'll close up, and we'll have a Q&A afterwards. So, all right, so let's try and manage our way back into normalcy after that. Do you want to kind of talk just high level? You talked about the audio while I put this down.
Yeah, sure. So, so as I said, Kinect has 4 microphones built into it, and so when you combine, those 4 mics with the tracking capability, the sound source localization, and also automatic gain control and echo cancellation, it actually becomes a very high quality microphone.
Right. And just to keep in mind, one thing in terms of best practices that we see with folks that have built Kinect titles on Xbox is multimodal, meaning it's not just an audio application, you're adding audio to an application. And here's just a good example of their engagement model where they use a mic indicator to say, hey, letting people know that you can talk to this application. And then the keywords to engage, like say, a command, say Xbox. Similarly, you see this so that like if you're talking to an application, you're not sure if it's actually listening or not. They have the levels, for example, that you can see whether things are actually happening. So in terms of speech recognition, you're going to show a speech recognition application in a second. The Kinect grammar, do you want to talk about that? Because we actually made that available as a download, and that's a big thing, I think, for anybody building audio applications.
So let's bring up Shape Viewer. Can you plug in...
yeah, let's plug in the correct Xbox
Kinect here, and we'll...
sorry, the correct Kinect.
I know, it's Xbox Kinect.
Okay.
All right, so we're going to fire up ShapeGate. So this actually comes with the Kinect SDK, and we thought we'd have a little fun in showing how you can use both voice and skeletal in a single app. So here I am, and I'm able to, kill shapes. So I can say red triangles, bright triangles, pause game. So now the game stopped. Continue.
Love it, love it.
You know, and along the bottom there, you see the grammar that I can use. Reset. Reset. There you go. So this specific game uses both, obviously, skeletal and the speech API. And we have a special language pack for the Kinect, which has been optimized for those 4 microphone arrays. So if we go take a look at the code itself, I'm not going to go into the rest of the code, which, you know, does all the shape game algorithms and rendering and so on. But looking at the recognizer piece of the code, this is for the speech bit. So essentially, we define what we want this game to respond to. And so this class here in recognizer is set up an enumeration of verbs that we wish to respond to, and then also some control information within the app itself. So obviously there's a string, which is, you know, the spoken word, and then also what we want it to correspond to internally within the app when that actually gets fired. So this initial set of code here sets up control structures in terms of what we want to respond to, and then also what we feed into the speech grammar itself. So obviously you can see the colors, the verbs that the game responds to, which are actions. This specific class here, this is the thing that gets fired when the speech engine gets an event, and this passes back to the game piece of the application. So when we create, initialize the speech engine, what we want to do is essentially request this specific language pack for the Microsoft speech engine. And so I said this has been optimized specifically for Kinect's microphone array. So what we do is we ask the speech engine to give us the recognizer info for this specific language pack, and we create the recognition engine itself with the ID that is returned. What we do now is essentially build our grammar up of the colors, the verbs, the shapes, and so on. So these are, you know, essentially just adding those to the lists. And then we set the action grammar, which actually gets passed into the grammar builder and loaded into the speech engine itself. We set event handlers for when speech is recognized, or if it hears something that that's not a verb, it will give a question mark event handler. And the DMO, so this is the DirectX media object. So this is how Windows surfaces audio. So this start DMO is a thread which essentially initializes the audio system in Kinect. Now we're not actually using automatic echo cancellation because because echo cancellation needs something to come out of the speakers.
Sure.
And so, you know, rather than creating a whole amount of code which renders silence in addition to the popping sounds, we kept it simple.
Sure, sure.
So we don't use echo cancellation in this example. And then we tell the speech recognition engine, you know, to use this speech format, and then essentially this kicks it off, saying that it's going to recognize spoken verbs asynchronously until it's told to stop, which is that piece of code there. So,
so that's what happens when those events fire, whether it's recognized, hypothesized, or rejected.
Right.
Sure.
So when a piece of speech is recognized, you know, we built our callback or event for, you know, something has been said, and then we essentially populate it based on what was said. So if it was a color, then obviously we set the RGB color that was spoken, so red triangles or something like that. Similarly, if it was a verb, maybe we said reset, obviously we don't need to set the color. So essentially all this callback does is set that event notification to the game piece of the code, which tells it what to do. Similarly down here, you know, if the verb is equal to paused, you know, then we, you know, set the pause flag, that kind of thing. So really, that's the nuts and bolts of speech recognition. It's really straightforward.
Great. Do you want to show the echo cancellation demo as well, quickly? Or
yeah, we can do that. So that is in much lower detail in C++.
Maybe just at a high level.
At a high level,
So
sure.
for people, and all those samples that you've shown, you know, we're going to have them, you know, some of them are going to be available on the web. The ones that ship in the SDK. So the shape game that you've shown.
So shape game, then there's a skeletal viewer both in C++ and in C#. Then we have several excellent audio samples. And the SDK, if you go to the Kinect website, it has some amazing documentation that, over 100 pages of documentation that you should go and read. And there's some very detailed walkthroughs for some of these SDK samples, which will really help, you pick up, the concepts here.
And we do have the Visual Basic examples as a download as well. It doesn't ship in the SDK, but they are available as a download for Visual Basic developers.
And how long did that take you to convert the skeletal viewer in C# to VB?
Time is nothing. That is the, but not a lot of time at all.
I mean, it was literally 10 minutes.
Yeah, it was a couple minutes. Now, one thing to note, and you'll look at it at the slide, there is one thing to do on bit shifting is different in Visual Basic. You actually need to cast to an int. The code is in there. That was the one real key change. So, but otherwise, just very, very simple, very straightforward.
Right. So if you want to build a C++ application that does echo cancellation, essentially this is it. There's some helper structures and classes here, which for writing the sound to a file. But the nuts and bolts is, this is our application entry point. Because we're capturing audio, we don't want to be preempted, if some other application gobbles up 100% CPU. So we want to set this application to have a high priority thread. We initialize the DMO, the DirectX Media object, just using standard COM. And then we get this property store object out of it, which enables us to control how it behaves using key value pairs. So once we have that, essentially we set, that we want it to behave in a specific way. So what we want here is a beam array microphone source using acoustic echo cancellation, and we set that value. This function, which is a helper function here, allows us to specify which audio capture device we want. In this case, it's a Kinect. And then we tell the DMO that we're using this speaker and this microphone away, and we pack those into basically a D word, and then we tell it to go. So because echo cancellation needs something to come out of the speakers, this is where we prompt the user to, play a sound. I won't go into that just to save time. Okay. And then essentially we record the audio, and it comes back as nicely cleaned with all of the speaker output removed from it. So you imagine at home you're playing a noisy game in Kinect. When you speak to the Kinect, under the covers it's getting crystal clear sound. So when you use echo cancellation, to do voice recognition,
it's removing the sound that it's playing and just gives you that clear sound.
Exactly, right.
Sure, great.
So in this D-Show record, we're basically setting the format that we want it to record in. And we obviously with output type there. And then we're basically creating a file into which to render it, and then here's the loop which gets, sample packages, off the device as they become ready, and we just write them to a file. So it's pretty straightforward. If we wanted it to behave without echo cancellation, we'd turn that key value pair off.
Sure, sure.
You can turn on gain control and so on. So there's a lot of great things. And also,
if you actually look at the Kinect audio source, the amount of properties that you can do to control the audio source are tremendous.
Yeah, I mean, another great thing is the sound source localization. So looking at this piece of code here, we can actually get the angle which it's detected a specific sound in relation to the Kinect. And Carlos, our audio engineer here, did all this work in engineering this piece of code. So if you have any questions, you can ask him how that specifically works. But as I said, it's with those 4 mic arrays plus, our algorithms, very high quality mic.
Yeah, absolutely. Yeah. Okay, so just jumping back into it, I think we are closing down. We saw some demos just at a high level. Do we want to bring in folks for Q&A? So we're bringing folks for Q&A, and while they're coming in, I'll be talking and just going through some of the downloads. So remember, it's available to download today, research.microsoft.com/Kinect SDK. Gavin mentioned that Kinect speech engine. That is available to download directly off the Kinect SDK as well.
So that's essentially a language pack that the main speech SDK and runtime actually leverages.
You want to slide? We're going to be a happy-go-lucky family here. we have those walkthroughs, 100 pages that you mentioned before, the Kinect Toolkit, which has some time savers, and then some quick start videos to just kind of walk through the real basics for videos. But, you know, this is all about interaction. So we've been talking too long, as is.
We have way too long.
We got to shoot Carlos and get video and images, so that's a wonderful thing. And I want to introduce you guys. So, Carlos, since we shot you, you get the honor of being introduced first.
I'm Carlos Garcia, and I worked on a lot of the audio support for Kinect, like Gavin described, the echo cancellation, noise suppression, all the sound source localization, all that fun stuff.
Okay. And Eric, you want to introduce yourself?
I'm Eric Rudolph, and I was working on the video portion and the capture engine and the GUI runtime.
Cool. So this part is really all about Q&A. So we send your questions. It's #CH9 live, #CH9 live, #CH9 live. I'm just going to keep saying it. Yes. Oh, sorry. Hash. Oh, these Australians. Everything's backwards. Okay. So we have questions from Twitter, and I'm going to read these off and then ask our esteemed panel here to answer them. So, @Waffles asks, will the code for these apps be available as demos?
Yes, they will.
Yes, they will. The one sample that we don't have is the one we pulled off kind of last second, which is the Nerf gun. We will be adding that. It probably needs a couple things, like I think it'd be nice if it could actually recognize different skeletons, so it doesn't shoot you, it only shoots intruders.
Right.
Or voice commands to stop. So maybe we'll make that a fun project, and people can contribute different ways to do that. And one of the things, you know, when we were talking about sound, you can use sound to help identify people as well. Based on we know the skeleton of Dan is 6'2", and therefore he is at this height, so we can kind of use that as one of the things to help identify who not to shoot. So if there's somebody that's 5'6" or something, they're going to get nerfed. So more questions. @RiderDam asks, how long until someone develops a visual IDE that uses the Kinect? How long? I actually think we're gonna have a demo. That was one of the teams. Do you wanna? You were there last night. Do you want to give a quick overview of your code camp experience?
It looked like they were getting pretty far with being able to learn gesture recognition. I don't want to steal their thunder, and I don't actually know too much about what they were doing, but I saw some pretty impressive stuff yesterday with skeletal smoothing and being able to train recognitions and to control the Visual Studio IDE from the Kinect.
Awesome.
Yeah, it's pretty neat.
Yeah. Cool. And we're going to keep those demos after this Q&A. We'll be going through more. And Scoutman PT asks, what speech API languages are available?
So for the first release, we have only an English language pack. The acoustical model, as Gavin described, was trained for the Kinect, but only for English for now.
Okay. @EvilSquid asks, are we going to see any Silverlight implementations of the Kinect SDK? So who wants to answer that?
I think Carlos can answer that.
Well, I know that. I mean, the current implementation is you cannot just out of the box run it inside Silverlight. Whether we have plans, like we can't quite say what we're going to build, but the current SDK you will not be able to use in Silverlight.
Okay, good answer. Good answer.
What does a Silverlight implementation mean?
So I think one of the challenges with Silverlight is you can't reference local .NET libraries the way you can in, say, WPF or whatever. So it would have to be out of browser COM and some of the COM activation things there. It's not a scenario. It's important to say that we haven't tested Silverlight as a supported runtime for application development. It's not something that we've done. So, next question is @Bradley Lones. I hope I got that right. For Kinect SDK, when you say non-commercial, what do you actually mean? Can we share our apps with the public? Gavin, do you want to answer this?
Yeah. Okay. So this initial release of the SDK is targeted towards enthusiasts and academics who wish to get their hands, dirty with programming NUI. So initially, it's for prototype use. Obviously, anybody can use it to come up with cool prototypes. At this point, it's not for commercial use, so obviously one can't build solutions, a third party can't, and then sell them on to.
Right, you're not selling your, your $10 application or something
Right,
like that.
but you can prototype with it.
Sure.
Down the line, there will be a commercial version of the SDK, which will enable, people to commercially build and deploy stuff. But at this point, this SDK is specifically for prototype use and development, just to get the newy juices flowing.
Okay, good answer, good answer. X Implosions X asks, are there going to be any samples for 3D scanning with skeletal tracking? So
I'd say come up with it.
Yeah, I think so. Really, what we wanted to do is kind of have samples that show you the capabilities of the API and show you, some fun examples as well. But even just with the code camp, things people are doing in 24 hours is amazing. So I think we're going to see a lot of things like 3D model viewers where if you have the position of a joint, you can actually do a skin on top of it. And I'm sure the DirectX folks will have a lot of fun there.
Mm-hmm.
At Edward Prentice asks, why can it only track 2 humans? Can this number increase?
Who wants to answer that, Eric?
I think mainly it's because the Kinect is optimized for living room use and optimized for having 2 people within the field of view. I think if you have more than 2, it would make the situation kind of complicated for the overlapping skeletons. I think if it had a wider field of view, I think it could recognize more than 2, but they just made it that way for optimized for home use and for the amount of CPU processing that we had.
Yeah, and also understand that the algorithms that in the last several months, that have gone into the Kinect SDK, they are the Xbox algorithms. And
right.
so, we want to use, those tens of thousands of hours of, code and bring them over to the PC platform. And so essentially we're on parity with the Xbox capability.
Right, right. Now, at Demahanta asks, is there any motor control in the SDK?
Yeah, we don't have gyroscope control, or we can't read the gyroscope with this release, but we do have motor control, and we can set and get the elevation.
Mm-hmm.
Yeah, yeah. At Martoons,
that's a good question.
Is it possible to connect more than one Kinect? So I love the answer to this. Who wants to answer?
Yes, you should. It is possible, but they use a lot of bandwidth, so you want to make sure that they're both connected to different host controllers. And on the second or further connect, currently you cannot do more than get video and depth feeds from it. You cannot get skeleton or depth plus index.
Okay, so it's really 2. One can get full skeleton, and then the other is getting color and depth.
Right.
Okay. Good answer. Good answer. At RCED, I feel like we're playing Family Feud. It's great. At RCED04 asks, can the SDK be used with ordinary camera?
Well, the Kinect SDK was written for the Kinect cameras.
Right, exactly right. So, and the most important part, I think, is that depth camera that's very specific to the projector that's built in and the sensor that's reading that depth data back. So I don't think there's anything really just RGB specific. You really need that depth data to do the processing.
Right.
So the next question is, at RRArg, I hope I got that right, wondering how easy will it be to write Kinect-aware applications? I will need to use CV libraries. So I think that refers to the open CV libraries for visual detection.
Mm-hmm.
As far as I know, you can use it. It's just a library. You send it data, and it'll be able to send you back.
This 3D skeletal data you get back, you should be able to put into the OpenCV stuff and render things based on the skeleton positions. There isn't any reason that I know of why you can't use it with OpenCV. But you don't need to use OpenCV to get skeletal data or to process the video in any way.
No.
You don't need it.
Yeah. Yeah, and I think there's going to be, plenty of examples out there where people start showing how to use these combination of libraries. And certainly, 3D libraries and other libraries that we've seen the community using already. At Timothy Soor asks, will the skeleton be extended to fingers? So who wants to talk about kind of the level of accuracy in terms of the joints and fingers?
Yeah, so currently the SDK, has the accuracy to track skeletons, again with Xbox parity. This beta period is for us to collect feedback from the community enthusiasts and prototypers so that we can, plan for future. Currently, we don't have finger tracking support.
Okay. Of course, the big things we're doing for a community, if somebody wants to take this and build stuff.
Well, I have seen people do finger tracking demos, but it's using the depth map.
Right, it's their own set of algorithms for that.
Right.
Yeah, and that is a good point. When you need that level of detail, you're really going down to that nuts and bolts, as we showed earlier, to get that depth data. So at Hot10 asks, will there be a For Dummies SDK being a new programmer using AngelScript? So I'm not sure what AngelScript is, but we do have a number. The best way, I'd say, for people to get started is, we have those series of quick start videos, we have the samples, and really just kind of
walkthroughs.
And the walkthroughs.
That's
It's really just download the SDK, and I'd probably just say get started. There's a number of tutorials as well on Channel 9 for programming basics. Search for Absolute Beginners. There's a great series, and it's Windows Phone specifically, but the first couple of videos are really all about Absolute Beginner's Guide to Programming. So if you don't know what a class is or what a for loop is, and those sort of programming basics, that will help you then when you look at the code understand what's happening with the Kinect SDK. So,
and as you saw, it only took, for Dan's original samples for capturing depth and video and rendering them, it was like 7 lines of code.
Absolutely. Absolutely. So at DD Reaper asks, are there any plans for a Coding for Fun basic mocap? I think that's Motion Capture Studio for the Kinect SDK. So, that's one of the things we're, for Coding for Fun, always looking to do fun, cool applications that use this. We have thought about doing basically a video recorder application. It was one of those things. Jeremiah Morrill, who's our expert, if you will. Unfortunately, he has a bunch of projects, but he assures me that he is dying to play with the Kinect SDK, and that we can release an open source sample that people could use to do, imagine just a video recording and also do audio as well. So it's one of those things that is definitely possible. The SDK enables it, and I think what we'll want to do is show the sample and then a reusable library. So good question, and hopefully something coming soon. So at Martoons asked, and we have just time for a couple more questions. How about the future of Kinect? Some HD cameras on?
So we're not going to talk about future revisions of the device itself. So
hooray! We're not going to leak. Yay!
Leave it at that.
Yeah. So that's a good answer. At GoThagus asks, XNA support for Kinect coming anytime soon? Who wants to answer?
We don't have any plans to specifically do that, but I think it would be good to get some XNA samples using the Kinect into the pipeline and in public as soon as possible.
Yeah, I mean, you should be able, they're complementary with one another because they're .NET, right?
Sure.
So.
Yeah, I think what you'll see in that, to use XNA, is because it doesn't use the events, it's more of a frame per second drawing style, is that you'll want to actually, what's the value to basically pull the camera data directly? I think
you can pull it.
Yeah.
You get the next frame.
We have seen some folks internally, I think there was a fun lightsaber demo.
Oh yeah, that's right.
That's actually written in XNA.
And we'll publish that.
Yeah, and the gentleman is going to publish that. So we will have some samples using XNA. So it's not, and one thing, just to reiterate that point on the UI libraries, do you want to talk about that quickly, and just so people understand the Kinect SDK and what's possible?
Yeah, so
I guess there aren't UI specific libraries.
Right. So the NIWI runtime itself is kind of UI-less, and it returns to you, obviously depth and image feeds and the Kinect data, the skeletal data. It's up to you what rendering mechanism you use, .NET or Win32 support.
I think one of the most important things to do for an XNA sample is to be able to get the video bits inside of an XNA texture and draw it. So that's one of the things I'm going to be focusing on first.
So Eric will write that up tonight.
Oh,
yeah.
I think you just took an action item. That's wonderful.
Yep.
So our last question here, at Ronnie's Wofford asks, what is the smallest distance the Kinect can register as a movement?
I have no idea.
Well, it depends. Are we talking skeletal recognition distance or depth? Because if you're using depth or VGA, then it's up to your algorithms. If it's skeletal, then it's a standard Xbox numbers, which are all in the online docs.
You know, depth is in millimeters,
Mm-hmm.
and it's fairly accurate. But the skeletal movement, it depends on how well the room is lit and how much motion there is in the picture.
Yeah,
all that
just
kind of
the
stuff.
standard Xbox numbers,
Yep.
which are all published.
Great. Okay, so thank you all. Resources, Eric, Carlos, Gavin, do you want to do the recap of resources for
Yeah,
where people can get
so-
stuff?
Get the SDK at research.microsoft.com/Kinect SDK. It's written at the bottom of the screen right there.
Yeah, yeah.
I've never been
That's
able
cool.
to do that before, so I'm glad I can do that.
That's wonderful.
Everything's on there. There's a forums link where you can go, ask questions, share your ideas with other people in the community. There's all the fantastic online documentation. So go there. You'll find everything that you need.